Hello my friends and welcome to this educational series in your favorite subject, chemistry. This video, my friends, is intended to be a quick revision and a short summary for the previous two classes after I have noticed that some students couldn't understand some points, so that we will revise this information and we will use it in order to answer those two questions. After answering those questions, I believe that the problem of making and naming chemical compounds is going to be solved once and for all. Allow me, my friends, before I start answering the questions, to give you a quick revision for the things we have taken so far. My friends, we started defining the ion, and we said that an ion, it could be one atom or a group of atoms that has a charge. And we said, my friends, that we classify the ions in two terms. The first one depends on the charges, and we said that we have two types. The positive charges, ions, we call them cations, while the negative ions are called anions. In terms of the number of atom of each ion, we said that a monoatomic ion is an ion that is made up of one atom, while a polyatomic ion is an ion that is made up of more than one atom that refuse to be separated ionically. Then, my friends, we learned how to make a chemical compound, or how to write a chemical formula. And we said that to write the chemical formula, we have three main steps. The first one is to put the positive ions or the cations left of the formula, while the negative ions or the anions should be on the right. And we said that we have two exceptions, those formate and acetate. And then, my friends, we said that we look at the charges. If the charges of the positive ion and negative ion are the same, for example, both of them +1, both of them -1, we combine them together without looking to the charges or to the numbers. And if they are different, in the second case, we should cross multiply them and use parentheses in the case of the polyatomic ions, while for the monoatomic ions, we keep them without using any parentheses. Then, my friends, we talked about the nomination of the chemical compounds, and we said that for the positive ions, they have the same names of their original atoms, while the names of the negative ions in the chemical compounds, whether they were monoatomic or polyatomic, are different in the chemical compounds. And again, my friends, we said that we have two options. The first one is when the negative ion is attached to any cation, here any positive ion, except for the H+, and then we said we have to add "-ide" for some monoatomic ions, and we use the 8 for some. In the second case, my friends, we said that if a negative ion or an anion is attached to a hydrogen ion, they will all be called acids, and we had two suffixes to be added. We have the ic acid and hydroic acid. Now, my friends, let's go and let's answer those two questions so that we can understand better. Before answering these questions, my friends, allow me to remind you of the importance of memorizing all the ions in this chart, so that when you go through any chemical reaction, you are going to be ready to answer. Here, my friends, I start with potassium. Potassium is K. And I have the dichromate. What is dichromate here? Dichromate, this is the dichromate, Cr2O7. Again, we have the potassium, which has the charge +1, while dichromate has -2. The ion left, the negative ion right. And then we have different charges here. I cross multiply them so that the potassium is going to be multiplied with 2, while dichromate is going to be multiplied with 1, which is not necessarily to be mentioned here at all. Then, my friends, we started the second one, the copper. We have copper 2. Here, copper, I have two options. So they said copper 2, it means this copper atom has lost 2 electrons to become copper 2 cation. I write Cu and here 2. Hydrogen phosphate. I have hydrogen phosphate here, hydrogen and phosphate together. Here HPO4. This is -2. So this is CuPO4. As you see here, my friends, the two charges are equal in terms of numbers, so that we can add them to one another regardless to the numbers or to the charges. I have aluminum dihydrogen phosphate. Aluminum dihydrogen phosphate, I have aluminum here, Al. Dihydrogen, D or di means 2. Hydrogen phosphate is PO4. This one, of course, -1, and this is +3. I cross multiply them. I have aluminum 1, and for the dihydrogen phosphate, I have H2PO4, and I write the number 3 here. For the ammonium thiosulfate, my friends, ammonium is NH4. Thiosulfate is S2O3, as you see here. This is +1, this is -2. Cross multiplying them, my friends, we will get NH4, which is multiplied with 2. And as long as this is a polyatomic ion, I should put it into parentheses so that I keep it as one atom. For the thiosulfate, it is S2O3 multiplied with 1, which is not necessarily to be mentioned. I have iron. Which iron? Iron 3. They chose iron 3 here in the example, Fe +3. I have bicarbonate, which is this one, HCO3 -1. I cross multiply them, my friends, again, and I get Fe multiply 1 with HCO3 multiply 3. Again, my friends, I would like to recommend revising the previous classes so that you remember the parentheses rule. Then, my friends, we started with lead 2, EPB. 2, we have acetate, CH3COO -1. This is the acetate. This formula, my friend, is not correct. This is wrong. Why? Teacher, generally we add the positive ion to the left, the negative to the right. Yes, my friends, but not with the two exceptions, the formate and the acetate. Here, the acetate should be left and the lead should be right. Here, as it is an exception, I write CH3COO 2PB. Then the first question is over. I will go to question number 2. I have H2SO4, and of course, this, my friend, is an acid. So I prepare ic acid. As long as your ic acid, I write it this way. As long as, my friend, we have a hydrogen ion attached to a negative ion, so it's going to be an acid. This one is an acid. Also, ic acid. Which one is also ic acid? Any other? No, no other acids. Here we have sulfuric acid, sulfuric acid. This have here, my friend, we have hydro, as we learned, for chloric, iodic, and bromic, and fluoric. We have the hydro affix here, hydrochloric acid. We have here formic acid, and here, my friends, we have silver, sulf. Again, my friends, as long as the negative ion is not attached to hydrogen, so it's going to be added to the suffix 8. We have silver sulfate. Here we have calcium, B, carbonate. Here, my friends, we have potassium. For iod, we said iodide, those chloride, fluoride, bromide, iodide, when they are attached to any positive ion or any positive cation except for hydrogen, we add the iodide. We add the ide suffix. Here we have ammonium sulf. sulfide because it's a monoatomic ion and it is not attached to hydrogen, it's not an acid. And we have here iron oxide. The problem is, my friends, that I have two options. Some students make a mistake of looking at this number and they say, teacher, this is iron 2. This is not correct. The number here doesn't represent which ion is the iron, because those are for cross multiplication. So I give them back to what they were. I have oxide -2 and I have iron here. So it's a plus 3y because I cross multiplied them. I get the same result, so it's iron 2 oxide. Well, that's it for today, my friends. Thank you for watching this video. I hope you enjoyed this class and you learned something and you revised something else with me. And please, my friends, if you don't understand a point, please try to repeat this video or play some Kahoot games which are related to the same topic. And again, my friends, don't forget to memorize this chart, because memorizing those ions, my friends, is going to be a very good of use for you in the next classes, even in the university, not just in the high school. And goodbye for the next classes, in which we are going to start learning how to write a chemical equation. Thank you, my friends, and goodbye.